Well, hello everyone. It's great to be here in Kiev. This talk is entitled Deep Dive into Eager Loading Limited Associations. Now, my name is Jeremy Evans, and I have been the lead developer of the Ruby SQL library for the past 6 years. And for those of you who haven't heard of the Ruby SQL library before, it is an SQL database library for Ruby, and it contains an object relational mapper that is similar in basic usage to Active Record. Now, we start this talk on a boat, getting briefed on the conditions underwater. And unfortunately, the water is murky, even though it doesn't look murky, and with only a few meters of visibility. Now, while I'm sure most of you are familiar with associations, let me briefly talk about associations in general. Now, associations are really a shortcut for querying for related objects in other tables. So let us consider a database that stores blog posts in one table and replies to those blog posts in a separate table. And here's a basic SQL model for the posts table. If you want to add a method that returns all replies for a post, a simple solution is something like this. Now, this adds an instance method named replies that returns all replies where the post ID for the reply matches the ID of the current post. Now, this is simple and straightforward, but since methods like this are very common, it makes sense to abstract them and offer a higher level interface. And that higher level interface is associations. So instead of manually writing an instance method to get the replies for a post, we call a class method that writes the instance method for us. Now, calling the replies method on a post instance then runs this SQL query and returns all related replies. Now, this works great if you want to get the replies for a single post object. However, what if you have multiple post objects and you want to get the replies for all of them? Now, you could just loop over the posts and call the replies method separately for each post. However, this will run a separate query for every post, which can be inefficient, especially if there is significant latency between the database and the application. Now, what would be optimal would be to run a single query similar to the one shown, which would return all replies for those 5 posts, and then automatically associate each reply with the correct post. And that's the reason that eager loading was introduced. Now, in SQL, the default eager loading method is called eager, and by calling eager, you tell SQL that you want to eagerly load the replies for all of the returned posts. So this will automatically run the query to get replies for those 5 posts, and it will automatically associate each reply to the appropriate post. Now, the reason for our underwater excursion today is to find out in detail how to handle the association correctly if it is limited to a given number of records. Now, here is an association that returns the first 10 replies for a post using the association's limit option. And generally, when you're adding a limit, you want to add an order as well so that you get consistent results. Now, assuming that the replies table has a typical auto-incremented primary key, ordering by ID should ensure that you get replies in the order that they were received. So taking the limit and order together, this association should return the first 10 replies received for a given post. Now, note that for regular association loading, when you have a single post and you just want the first 10 replies for that post, the query to use is simple. You start with the initial query that you use for regular loading. You then order by the replies ID so that earlier replies come before later replies. And finally, you limit the number of returned results to 10 using the limit clause. Now, while the strategy works fine for loading the replies for a single post, it cannot be used for eagerly loading. So let's look back at the query used for eager loading, and let's try to apply the same strategy of using the limit clause. You would end up with the SQL used here. And the reason this does not work is that the limit 10 clause here applies to the entire result set, giving you the first 10 replies to any of the 5 posts. So this may return 5 replies each for post 1 and 2, and no replies for posts 3, 4, and 5. What you want is the first 10 replies to each of the 5 posts, which the limit clause cannot handle. So if you cannot use a limit clause to do eager loading, how can you get correct results? And to find out you cannot stay above the water, you need to dive in. And just like you have rules when diving, I think there should be a rule for eager loading. And that rule is, eager loading an association for a group of records should give the same results as loading the association separately for each individual record. Now, eager loading should be considered an optimization, and if it changes what values are returned, I think it is broken. Now with SQL, this rule should be followed for limited associations. If you are eager loading the first 10 replies for a set of posts, calling the first 10 replies method on any of the return posts will return an array containing the first 10 replies, even if the post has 1,000 replies. Now this is not true if you are using active record. Active record's documented behavior for eager loading an association with a limit is to ignore the limit. So if the first post returned has 1,000 replies, calling the first 10 replies method here will return an array containing all 1,000 replies. Now, it cannot really be considered a bug as it is documented. It does violate the rule as eager loading changes the results of the first 10 replies method. And it certainly would be nice if the behavior could be changed so that it did not violate the rule. So since we are still on the surface, let's consider simple ways to handle eager loading limited associations correctly so that the rule is not violated. The simplest way is just to not eager load in that case. Basically, if you're asked to eager load an association with a limit, just do not eager load. When the first 10 replies method is called for each post, issue a query to the database to get the first 10 replies for that post. Now, if you are only eager loading for a small number of posts, or the latency between the database and the application is low, this performs quite well in most cases. However, as the number of posts you are eagerly loading for increases, or the latency between the database and the application increases, performance does start to degrade. And another simple way to handle eager loading limited associations is to eagerly load all associated records, but take the resulting array of replies for each of the posts, and then use array slicing to extract the first 10 replies before returning the results to the user. Now, this was SQL's original strategy for eager loading limited associations. And what SQL does is fairly simple. It just uses a range to slice the array to return only the first 10 replies. Now, at a database level, this does not perform any differently than active record's approach of loading all objects. And in many cases, it performs worse than skipping the eager load. But it does at least ensure that the user gets correct results and that the rule is not violated. Now, while skipping the eager load or slicing the resulting array are easy solutions, what would be better would be to send a single query to the database that returned the first 10 replies for each of the posts being eagerly loaded. And it turns out there are multiple ways to do that in SQL. However, you need to leave the shallows and dive deeper to figure it out. Now, one strategy that uses a single SQL query to eager load limited associations is to use a correlated subquery. Now, a correlated subquery is when a subquery references columns from the query that contains it, and for each row returned by the outer query, the subquery is evaluated separately. Now, here is the SQL that implements a correlated subquery strategy for eager loading. It's basically the same query as used for eager loading without a limit, but with the addition of the highlighted subquery to remove replies that would not be in the first 10. Now, the highlighted part here shows the correlation. The subquery's where clause filters for rows where the replies in the subquery have the same post ID as the replies in the outer query. So the where clause in the subquery makes it so the subquery consists of only rows in the replies table that have the same post ID as the current row in the main query. The limit clause in the subquery then ensures the subquery consists of only the first 10 rows in the replies table that have the same post ID as the current row in the main query. Since the subquery now returns the IDs of the first 10 replies for the current post, the outer query can use an in clause, which will remove replies where the reply is not in the first 10 replies for its associated post. Now, unfortunately, this approach can be slow for large data sets, unless the database is very good at optimizing for correlated subqueries. And it's not too difficult to determine why. So let's say that posts 1, 2, 3, and 4 have few replies, but post 5 has 10,000 replies. Unless the database is good at optimizing correlated subqueries, what the database will probably do is run this subquery for every one of the 10,000 replies to post 5. Note that it is possible for the query to be optimized such that this subquery is only run 5 times. Now, a good correlated subquery optimizer will realize that the only expression in the subquery that references the outer query is the highlighted replies.postID. And since this is the only expression in the subquery that varies based on the current row in the outer query, you can cache the results of previous subquery evaluations by the post ID and only reevaluate the subquery if you see a post ID that is not in the cache. And this is one area where Microsoft SQL Server's optimizer is significantly better than PostgreSQL's optimizer. On Microsoft SQL Server, using a correlated subquery for eager loading can be faster than the default of slicing the array, but in PostgreSQL, it can be orders of magnitude slower. Now, unfortunately, while most SQL databases support this type of correlated subquery, MySQL will not even execute it, as it does not support using a limit clause on a subquery that is used in an in clause. Now, SQL added support for using correlated subqueries to do eager loading in SQL 3.28. However, because on databases without good optimizers it performs poorly, and databases with good optimizers can use a more performant approach, support for using correlated subqueries for eager loading was removed in SQL 4. Now, another strategy to eager load limited associations in a single query is to use a window function to compute the order of replies for each post. Now, window functions are similar to aggregate functions, but instead of using group by to combine multiple input rows into a single output row, they compute their results based on a set of rows related to the current row called a frame. That's probably a little bit hard to understand, so let me provide a simple example. Now, consider the following data set of replies, which I have stripped down to just the two columns we are interested in, the ID and the post ID. Now, in this case, there are 3 replies to post 1, 2 replies to post 2, and 1 reply to post 3. And we can use a window function to determine the order of replies for each post. Now, that window function is called row number, and what this row number window function call does is provide a number for the position of the reply relative to other replies with the same post ID. So as you can see, window functions are specified by using the over clause after the function call. And this over clause contains a partition by clause, which specifies the column or columns that you want to use for the grouping. Now, here we are partitioning by post ID, which means that the row number calculation is done separately for each set of replies with the same post ID. We are also specifying an order by clause, which specifies in which order the individual rows should be processed inside the partition. Now, here we are ordering by the replies ID, so that for replies with post ID 2, it will process reply 4 before reply 5. Now, putting this all together, what the row number window function does is for each of the reply to post 1, it orders them by their ID. So the first row has the row number of 1, the second row has the row number of 2, the third row has the row number of 3. Likewise for post 2, first row has row number 1, second reply has row number 2, and for post 3, there is only a single reply, and that reply has row number 1. So now that we know how to specify the order of the rows, let's apply this to eager loading. You start by taking the basic eager loading query that uses in with the key values. Now, what would be nice is if you could just use the row number window function in the where clause to remove rows that are over the limit for the association. And unfortunately, that does not work, as it is not valid SQL syntax. And the reason for this is that window functions are not computed until after the where clause has been processed, since the where clause modifies the inputs to the window function. So you cannot use window functions in where clauses. Since you cannot use a window function in a where clause, you have to move it into the select clause. Now, note that this does not remove replies that are over the limit. It just returns the row number as an additional column. In order to remove replies that are over the limit, you need to make the query a subquery and select from it, and have the outer query use a where clause to remove replies where the row number is over the limit. Now, this can be significantly faster than skipping eager loading or slicing the resulting array. And unfortunately, it is still suboptimal. Considering our earlier example with 10,000 replies for post 5, this will probably compute the row number for all 10,000 replies returned by the subquery, and then later remove 9,990 of them in the where clause in the outer query. So unless the database's query optimizer is smart enough to avoid computing the row number for rows after the limit, using a window function will always be suboptimal for eager loading limited associations. Additionally, window functions are not supported on simpler databases, such as SQLite and MySQL, so you will have to use a different strategy on those databases. Now, the window function strategy was the first SQL eager loading strategy added to SQL in SQL 3.28, and it became the default eager loading strategy on databases that support window functions in SQL 4. Now, so the main problem with using window functions is that it computes the row number for all rows after the limit. And similarly, the main problem with correlated subqueries is that they also perform unnecessary processing. Now, is there a way to avoid unnecessary processing when you're doing eager loading? And there's actually a fairly simple way to do so. You can use a union to combine the results of each of the queries that you would use when regularly loading. Now, the union strategy requires a significantly different approach than the other methods previously discussed. Instead of starting with a query for unlimited association and then adding a filter to remove replies that are over the limit, you just union separate regular association queries. Now, it would be nice if you could do something like this, just sticking a union all in between all of these separate clauses used to regularly load the association. Now, unfortunately, SQL is not that simple. The union clause needs to come before the order and limit clauses in SQL. So what you need to do is wrap the queries in subqueries. Now, this certainly looks ugly, but this is the fastest way to eagerly load associations with limits. As virtually all SQL databases support the union all clause, this strategy is more widely applicable than the window function strategy. It even works on MySQL. So as I mentioned, this is the fastest way to eagerly load associations with limits. It's faster than the correlated subquery and window function strategies on all databases I've tested on because it avoids unnecessary processing. Note that it is only the fastest if you index correctly. If you do not index correctly, it is much slower than the window function or array slicing strategies, since it will do a sequential scan of the replies table for every post you are eagerly loading for instead of a single sequential scan of the replies table. So how does a union query avoid the unnecessary processing required by the other strategies? And it is because for each subquery in the union query, it can use a single index, read only the number of index entries specified by the association limit, fetch only those rows from the table, and move on to the next subquery. This avoids processing rows beyond the limit for the association, which is why it is the fastest strategy. Now, unfortunately, there are some problems with the union approach. On PostgreSQL, somewhere between eager loading replies for 5,000 posts and 10,000 posts, you start hitting the default stack limit of 2 megabytes. Now, you can increase PostgreSQL's stack limit up to 32 megabytes, but at some point you're going to hit a stack limit and the query will fail. The union approach also takes significantly more memory than the window function approach, so you are more likely to hit a memory limit as well. Now, the good news is that these limits are easy to work around. So instead of sending a single union query with 10,000 subqueries, you can send 10 union queries each with 1,000 subqueries, or 100 union queries each with 100 subqueries. Now, in my testing on PostgreSQL, I found that sending a single union query with 1,000 subqueries was significantly slower than sending 10 union queries each with 100 subqueries, which surprised me. And it turns out that a union query with 200 subqueries is more than 2 times slower than a union query with 100 subqueries. However, if you decrease the number of subqueries per union query, you increase the total number of queries that you have to send to the database. And what I have found is that on PostgreSQL, the optimum number of subqueries per union query is actually a function of the latency between the database and the application. So on a local database where there is almost zero latency between the database and the application, the optimum number of subqueries per union query is between 5 and 20. If you are using Amazon Web Services with different servers in the same availability zone, there is about a half millisecond latency, and the optimum number of subqueries per union is between 20 and 30. The database is in a different availability zone in the same data center with a 2 millisecond latency. The optimum number of subqueries per union is between 40 and 50. And if the database is in a different data center with a 20 millisecond latency, the optimum number of subqueries per union is between 100 and 150. Now, in most cases where SQL is used, the database is probably in the same data center, so SQL assumes about a 2 millisecond latency and therefore sets the default number of subqueries per union query to 40, and users can modify this value via an option. Now, eager loading limited associations via a union was added as the default strategy in SQL 4.10. You can still select the window function or array slicing strategies manually for the rare cases where they are faster, such as when the table does not have the appropriate index. Now, there's actually another strategy that SQL uses to eager load limited associations, but it is specific to PostgreSQL and only works with singular associations. So let's say instead of wanting the 10 replies for each post, you only want the first reply to each post. With SQL, you could set this up via a one-to-one association as shown here. Now, eager loading the first reply for each post on PostgreSQL can be done with this query, which uses distinct on. Now, distinct on is a PostgreSQL extension that allows you to specify arbitrary extensions, or expressions, on which the query can or should return distinct results. And this is different than a plain distinct clause supported by other SQL databases, which considers all selected columns. Now, here we are using post ID as the column to be distinct on. And this makes sure that the results only include a single row for every post. Now, when using distinct on, you must have an order by clause that starts with the expressions in the distinct on clause. So we first order by post ID. After ordering by post ID, we order by ID, and this ensures that the first reply received is returned for each post. Now, using distinct on performs better than the window function or correlated subquery strategies. If you are eager loading for a large number of posts and none of them have a large number of replies, distinct on can perform even faster than union strategy. However, in most cases, performance with a distinct on will be worse than a union strategy if any of the posts have a large number of replies. And the reason for this is that distinct on requires unnecessary processing. It requires loading all of the replies for each post and then removing all replies except the first one for each post. So if post 5 has 10,000 replies, and this loads all 10,000 of them, and then the distinct on clause removes 9,999 of them. And for this reason, the union strategy is still used by default for singular associations, even if the distinct on could be used. Now, so far, I've just been discussing query per association eager loading, and that is because it is the simpler case. Handling eager loading when using joins is even more complex and requires diving even deeper. So first, let's discuss why you would want to eager load via joins at all. And here are a couple of examples. If you want to eagerly load replies for multiple posts, but you want the posts to be ordered based on the time of the first reply or the most recent reply, you need to join. If you want to eagerly load replies for multiple posts, but you do not want posts unless they have a reply within the last hour, then you need to join. So let me briefly describe how eager loading via joins is done for an association with no limit. In SQL, the method that does this is called eager graph, and it has the same API as the eager method. Now, this method selects all of the columns of both tables explicitly, specifying aliases where the column name would be ambiguous. It then joins replies to posts via a left outer join, so that the query will return posts that do not have any associated replies. Note that we are specifying an order by replies.id, so that the query will return posts in the order of the earliest reply. And this is the reason that we have to eagerly load via joins instead of issuing a separate query for the results. So let us consider the case where you want to eagerly load the first 10 replies for each post via joins. And here is what the basic SQL would look like without any limits applied. Note that you cannot just add a limit clause. This is because a limit clause here would operate on the joined result set, which will almost certainly not give you the results that you want. If you add a limit 10 clause here, you might only get post 1 returned instead of getting both post 1 and post 2. So the rule that eager loading an association for a group of records should result in the same rows returned as loading associations separately for each individual record still applies when you're eager loading via joins. So what strategies can you use when eager loading via joins so that the rule is not violated? Well, first, you cannot skip eager loading in this case. Since the associated table has been joined into the query, there is no way to undo that. However, while you cannot skip eager loading, you can still slice the resulting array of replies for each post after eager loading. And just as in the query per association case, this does not save you anything at the database level, but at least it returns correct results. Now, array slicing is SQL's default strategy when eager loading via joins. Note that just as in the query per association case, active record does not even do this. It will return an array with records beyond the limit. Now we can also eliminate the union approach. We do not know which posts will be returned until the query is run, and therefore we do not know which subqueries to use in the union query. Now it is possible to use correlated subqueries for eager loading via joins. This SQL query implements a correlated subquery strategy for eager loading via joins, and the approach is similar to the approach used for a separate query per association. Now the main difference is that we filter the associated table before joining using the highlighted inline subquery. Now this subquery uses an in expression with a correlated subquery to filter rows that are over the limit for the association. Now in PostgreSQL and Microsoft SQL Server, this approach can perform decently, sometimes even being the fastest implementation. On databases with poor optimizers, such as SQLite, it can perform orders of magnitude slower in some cases. Now in SQL, to use a correlated subquery strategy for eager loading via joins, you have to use a method called eagergraph with options. And that's because the eagergraphs API does not allow for an options hash. Now SQL cannot determine the optimal strategy for eager loading via joins because it depends on how many replies and posts would be returned. So for this reason, you must specify it manually on a per call basis. Now using correlated subqueries for eager loading via joins was added in SQL 4.10. And while in some cases it is much slower than the other strategies, there are situations where it is the fastest strategy. In general, it performs best for eager loading for a small number of posts and worse for a large number of posts. Now you can also use a window function for eager loading limited associations via joins. And this SQL query implements a window function strategy for eager loading via joins. It's similar to the approach used in the correlated subquery strategy. The main difference is that the subquery uses a row number window function instead of a correlated subquery. So as when using a separate query per association, you cannot filter directly via a window function. You have to select the window function value in a subquery and then filter the results of the window function in the outer query. So in general, the window function strategy is the fastest strategy when the number of replies are large, and it performs worst when the number of posts is small. Now support for using window functions for eager loading associations via joins was added in SQL 4.8. And it is not used unless you specifically select it as an option, as it can perform much worse than the default array slicing in cases where the number of posts is small. Now for singular associations on PostgreSQL, you can also use a distinct on approach for eager loading via joins. In the interest of time, I will not be going over the SQL used, as it is similar to the other strategies. Now distinct on is always faster than window function strategy, but it can still be much slower than the correlated subquery strategy in some cases, and still much faster than the correlated subquery strategy in other cases. And likewise, it can be much slower than the array slicing strategy in some cases, and much faster than the array slicing strategy in other cases. Note that if you are filtering by or ordering by columns in the associated table, the results significantly change between using array slicing in Ruby and using an SQL-based strategy. So let's say you want to eagerly load the first 10 replies to post 1 and 2, but you only want posts that have a reply that contains the word diving. If you use an array slicing approach, this will look for replies that contain the word diving and return the first 10 of those replies. If you use one of the SQL-based approaches, this will take the first 10 replies for each post and remove replies that do not contain the word diving. So let's say that post 2 has 100 replies and only the 50th reply contains the word diving. With an array slicing approach, this will return post 2 with the 50th reply associated. With an SQL-based approach, this will not return post 2 at all, since none of the first 10 replies to post 2 contain the word diving. Now, I do not think there is a single correct approach here. There are good arguments to be made for either approach, which approach you would like to take. Now, for a many-to-one association, this is basically sugar for using objects instead of their foreign keys when you're filtering. Now, to filter by an association, you can use the association symbol as a key in a hash that you pass to the where method. It will recognize that an association was used, and instead of using the post column, it will use the foreign key of the association, which is post ID, with the primary key value of the object you pass in, which in this case is 1. Now, SQL goes a step farther than active record, allowing filtering by all types of associations. So this code allows you to select all posts that have that reply. And since this is a one-to-many association and not a many-to-many association, this should return a single reply, or the single post associated with that reply. Note that while active record appears to support this syntax, it will generate incorrect SQL, in the worst case resulting in silent failure. Now this is the SQL that would be used. It's nice and simple, it's just looking for all posts with an ID of 1. And since ID is the primary key, this should return a single post. Now consider the case where the association you were filtering by has a limit. Now in this case, using the same query is incorrect. The reply might be the 100th reply to that post, in which case it is not one of the first 10 replies, and therefore the query should not return any posts. So how can you handle filtering by limited associations? And just as in the eager loading cases, there are strategies that you can use. In general, variants on the strategies used for eager loading via joins will also work for filtering by limited associations. Well, as you are not eager loading, and you must add some sort of filter to the dataset, you cannot avoid the problem by skipping it. Unlike when using eager loading, there is no way to slice an array to fix the problem. And that's because in the eager loading cases, you end up with a separate array of replies for each post, which you can slice based on the limit for the association. In the filtering by associations case, it returns an array of posts, so you cannot reuse the association limit. You must handle the issue purely at an SQL level in order to get correct results. Just like when eager loading via joins, you cannot use a union approach since you do not know in advance the related posts. Similar to the eager loading cases, it is possible to filter by a limited association using a correlated subquery. So here is the filtering by associations query, and we need to add a filter to this query that will remove posts if the reply is not in the first 10 replies for that post. And here is a filter that can be added to the query that will remove such posts. Now this filter uses in with a subquery to restrict the return posts to ones that contain that reply in the first 10 of their replies. Now the subquery has two conditions. One condition is that the replies ID is 2, since we are only interested in posts that have that reply. And the other subquery is the more interesting one. This uses the additional subquery within, which removes rows from the outer subquery that are beyond the limit for the association, using pretty much the same correlated subquery strategy that you've seen while eager loading. Now, this approach is actually quite fast if the number of posts being matched is small and the number of replies for each post is not too big. However, for a large number of posts to replies, it can take a very long time. Now, just like when eager loading via joins, using a correlated subquery strategy for filtering by limited associations was added to SQL 4.10, and it is the default strategy used on databases that do not support window functions. As you might expect, the other strategy for filtering by limited associations is using window functions. Now here is the SQL for the window function strategy. It is basically the same SQL as used in the correlated subquery strategy, except for the inner subquery. Now instead of a correlated subquery, it uses a window function, and just as before, since you cannot filter directly on the window function, it has to run the window function in a subquery and then filter that in the outer query. So instead of 2 nested subqueries, this uses 3 nested subqueries. Now, unfortunately, it's not all roses with the window function approach, especially in the case where you're only looking for posts using a single reply. The correlated subquery approach can be much faster. However, the window function approach is more consistent and deals better with larger data sets. At least that's true on PostgreSQL. On Microsoft SQL Server, the correlated subquery strategy was always much faster in my testing. And the correlated subquery strategy also works on databases that do not support window functions, so it has wider applicability. Anyway, support for using window functions to implement filtering by limited associations was added in SQL 4.8. And just as in the eager loading cases, for singular associations on PostgreSQL, you can use a distinct on strategy for filtering by singular associations. Now, it's generally the fastest strategy, so it is used by default when filtering by singular associations. As before, in the interests of time, I will not be showing the exact SQL for the distinct on strategy, as it is similar to the other 2 strategies. So to review what I discussed today, I started the talk with a basic discussion of loading associations, as well as a general rule that eager loading an association for a group of records should give the same results as loading the association separately for each individual record. I then talked about easy ways to handle that, such as skipping the eager loading and falling back to regular loading, or using array slicing to at least return the correct results. I then talked about eager loading limited associations using a separate query per association. And I compared the union, correlated subquery, and window function strategies, and explained why using a window function, or using a union is almost always the fastest approach if the table is indexed correctly, and it works in the widest variety of databases. I then talked about eager loading limited associations using joins in a single query. I talked about how array slicing can still be done to get correct results at the Ruby level, and also showed how to join to subqueries that use correlated subqueries or window functions to limit results correctly at an SQL level. And I also explained that when you are filtering or ordering based on columns in the associated table, the results change based on whether you are using an array slicing or SQL-based strategy. And finally, I talked about filtering by limited associations and how no approaches at the Ruby level can handle them, and how correlated subqueries and window functions can be used to filter by limited associations at the SQL level. Now, in the interest of time and your collective sanity, I did not even talk about more complex cases, such as handling limits for associations with one or more join tables, or associations that use composite keys, or associations that use conditions or offsets in addition to limits. But worry not, as SQL handles all of those cases for you. And that wraps this presentation up. Thank you very much for taking the deep dive with me today.